Hello, I'm going to demonstrate this RF function generator that I built. I built it from plans from a Nuts and Bolts magazine. This magazine here from June of 2014. Just taking a look at it from the outside, I put in the back one of these computer style input things with a power switch. Nice to have the power switch next to the other AC wiring. And an RFI filter. Also got a couple jacks on the back for 12 volt accessory if I want. Set it back down. Turn the power switch on. Okay, it is now. So, going through the controls on the front of it, I have a selector switch here. This allows you to select which band you're going to use. It starts at about 188 kilohertz on the very lowest band. So we can run that down. And then, you increase it. There's a 250 kilohertz band, 400 and some odd, 500 and something. All the way up to, eventually you'll get up to about 120 megahertz on the topmost band. There is a coarse frequency adjust, so we can adjust our frequency up. The first band goes from about 188 to about 415. I've actually got my frequency counter over there showing that we're reading the same frequency on the display on the RF generator as on the frequency counter. So that was the coarse control. There's also a fine control, which I think does about 10% of the coarse control. So if we wanted exactly 218 kilohertz, we could just very carefully adjust that down. A little more. There, and we've got about 218. So we can go up into one of the megahertz bands. There we've got about 1.2 megahertz. Down to 900 and some odd kilohertz. Up to 2.4 megahertz on that particular band. I have a cable here. This is the RF out, which I have going into the frequency counter. I have two other jacks on the front. This one here is the voltage that is being applied to the voltage controlled oscillator, and I broke that out on the front so that I can actually switch off the internal voltage supply. You'll see the display start to go wonky because it's no longer supplying a voltage to the VCO. Then I could connect something over here to run an external voltage supply to the VCO in case I want to do like a sweep generator or something. And finally over here is an AM modulator. The AM modulator has an amplification control, so if I had some kind of AM, we could hook it up to there, adjust this to how much we want to modulate, and then it would modulate the output signal by that AM. This here is the RF output control. It's just like a 500 ohm pot. Not a fancy attenuator, but it gets the job done. The display here, this came from eBay for about $10. There's several different frequency counter modules you can get on eBay. It's nice because it allows you to see what you set here on the display. We can verify that we're getting, about the same thing on the eBay frequency counter as on the real frequency counter. About 2.265 megahertz. Okay, let's take a look at the bands that this thing produces. So we're on the lowest band, which you have to get it up to about 180 some odd kilohertz before it gets stable. There we've got 180, 185, 186 kilohertz. This band goes up to about 415. That band was with a 4.7 millihenry inductor. This next one is a 2.2 millihenry inductor, and it's going from 200 kilohertz up to about 617 kilohertz. It was a 2.2 millihenry. Now we've got a 1 millihenry, which is going from 350 kilohertz up to just shy of a megahertz. Then we've got a 680 microhenry inductor. He's going from around 405 kilohertz on up to about 1.1 megahertz. We pop over and look at my frequency counter, which is also plugged in. We'll see it's getting within four digits, the same number, 1.100. 1.100. Let's see, that was a 680 microhenry. Next band is a 150 microhenry, and it's going to go from about 875 kilohertz to about 2.4 megahertz. Next up we have a 47 microhenry. He's going from about 1.5 megahertz up to 3.9, just shy of 4 megahertz. Now we've got our 10 microhenry. It's doing from 3.5 megahertz on up to 10.5 megahertz. Next up is a 2.2 microhenry. There we've got 7.6 megahertz to about 21.5 megahertz. Finally, we've got a 330 nanohenry inductor. It goes from, on the low side, just under 21 megahertz up to about 55 megahertz. So that was it for the inductors that I was able to buy. The next inductors I hand wound myself from just a chunk of metal. This was some green Radio Shack wire. These start to get a little bit wonky and gets a little bit unstable. We start out about 31 megahertz. Don't know how many microhenries this is, or nanohenries, because I made it. Increasing it, we're up to 40 megahertz. We're up to 65 megahertz. The eBay frequency counter, I think it has to do a band change itself to 76, 77. See, once we get past about 76, so 72.8, that's working fine with the frequency counter. But if we bring it up to, there we're at about 82 megahertz, and the frequency counter is having some kind of issue with picking up its count. It's reading 75, it's reading 82, so maybe the eBay frequency counter module is maybe it's not quite up to par with these higher frequencies. The next band, this is actually just a straight chunk of wire. I don't know how many nanohenries that is, but probably not very many. It's reading 43 megahertz. Increasing it slowly up to 57, or up to 73.44. Got the same thing on the frequency counter. Running it up higher. See right here, we watch this. I think what it does is it starts reading a harmonic. So what we should have is about 75 and it's reading 150. Now it's going nuts. And then all of a sudden it starts working again. So we're at about 103 megahertz, 103.7. Both of them are good. Up to 110.8 megahertz. And there we have the frequency generators topped out at about 125 megahertz. Just a fine control up, see just how high it goes. It's actually 126.29. So, this thing seems to be working pretty good. The only thing is, just kind of in the middle here where we should be reading, somewhere around 90 megahertz. Instead, the eBay meter's going nuts. The frequency counter's going nuts. We've kind of got this wonky zone between, 70 or so. See there, it's 67, 68. Then it just starts going nuts. And then we get up to 170 and it's good again. So I need to put the scope on that and figure out what's going on. I would imagine it's picking up some harmonic frequencies or it's getting some RF interference. Maybe we're tuning an FM radio station into this. The author had some ferrite beads that I haven't added to mine yet. But that is a demo of the RF signal generator that I built from a Nuts and Bolts article. So let's take a look inside the RF signal generator. I followed the design from the Nuts and Bolts magazine. I made a few changes along the way, which I will describe. So let's start from where the power comes in. Power comes in through this EMI RFI filter with power receptacle and power switch. You can buy those from a place like Jameco Electronics. It's kind of nice because it has all the EMI RFI filtering, switches, fuses, all that junk in one spot. Keep your power switch on the back and it's close to the transformer. You don't have power wires going back and forth to the front. That feeds this transformer here, this 24 volt center tap transformer. That feeds this power board that I assembled from some perf board. It has 4 regulators on it. So over here we have a 7824, 2 7812s, and a 7805. The 7824 supplies power to the RF amplifier. The 7812, one of them runs this eBay counter module. The other 7812 runs this op amp board, and the 7805 is our power to the RF board. Originally, I was really trying to get by with just one transformer and single supply op amp, so I wouldn't have to have the complications of having a negative voltage supply and X transformer and all that junk. That almost worked, but not quite. It worked for everything except the AM modulator. I just couldn't get AM modulator to work without having a dual rail op amp with a negative supply, so that led me to add the second transformer. This little tiny guy came from Radio Shack. This PC board is one of my old 3-terminal regulator boards, and it's rigged up to give us a minus 12 volt supply for that op amp. Really tried to avoid that. Back here we have a couple of banana jacks, which will let me run 12 volt to an accessory if I wanted to. Draws off the same 12 volt regulator that this eBay display module draws off of. The next board here is the op amp board. It serves 2 functions. One of them is a summing op amp, which is connected to the coarse and fine potentiometers. This is basically described in the Nuts and Bolts article. I made a few changes, like I used a LM358 op amp instead of whatever they used. I've used a different Varactor diode, so rather than having a negative output voltage out of the op amp, I have a positive output voltage. All that seemed to basically work. Yeah, so the one function was to do the summing and buffering of these two pots. The other function is to do the AM modulation. So basically, AM signal can come in from the jacks on the front panel. It gets clipped to 1.4 volts peak to peak, goes through a unity gain op amp, and goes out here to the RF board. Next up here we have an eBay display module. You can get these frequency counter modules on eBay. They cost about 10 bucks. Takes you like 3 weeks to get one from China. And it can display frequencies from, I don't know, like a hertz to a gigahertz or something. It's a pretty flexible module. Did seem to have a few glitches while I was running it, and sometimes it will it seems to have to internally switch its algorithms between bands, so sometimes it'll get stuck trying to display kilohertz when it really should be displaying megahertz. So it's not perfect, but you know, it's 10 bucks. So that got us through all of the really simple circuitry. The complicated thing is in this this board here. This is the main RF board. I went ahead and I typed in the schematic from the Nuts and Bolts article, and I put it in Eagle. I ran it through Eagle's router, and I had Oshpark make me one of their little purple circuit boards, because I really hate point-to-point wiring. It's kind of complicated circuits, so laid out a circuit board for all of that. This here is an MC1648. That is the oscillator chip. There's a Varactor diode buried in there. Now the one the author recommended in the article, I couldn't find that sucker anywhere. It just seems to be unobtainable. But I did find a guy on eBay selling some MACOM hyperactive Varactor diodes part 45T079CK-287T. So I got, 15 of those for, I don't know, 10 bucks or something. Put one of those in there. The polarity on the diodes is different, so that it's kind of it's a double diode. It's a 3-pin package with 2 diodes, either common cathode or common anode. Whichever one I got is the opposite of the one the author in the Nuts and Bolts article used. So whereas he used a negative voltage to control his VCO, I use a positive voltage to control my VCO. Seems to work just fine. Everything else on this board, I think, is pretty much the way the schematic laid it out. I didn't take the greatest attention to being real tidy with my RF signals. For example, I've used these 2-pin headers where I probably could have put, a nice RF jack and used a shielded cable, but, this hobbyist level equipment is what I've built. So the interesting thing here is this selector switch. This is a 12-position selector switch. It's continuous rotation. That's not really important as continuous rotation, but that's what I found on eBay. Got a whole bunch of them for a cheap price. And on the back side of it here, you take and you hook a bunch of inductors. So first half of the video, I enumerated out, 4.7 millihenry, 1 microhenry, whatever. All of those inductors, they all go to different positions on the selector switch. Back here, I cut out a chunk of PC board, drilled some holes in it, so we've got, a plane that attaches one pole of all these inductors. We have a couple caps that ground that plane. We've got one wire goes to the inductors on the ground plane, the other wire goes to the selector switch. Most of these inductors came from an eBay assortment where I was able to get a whole bunch of these cheap little green inductors, like 20 different values and 10 of each for like 20 bucks or something. One of them, this 330 nanohenry, either from Jameco or DigiKey, I don't remember. These are the ones I tried to wind myself. This was just some green Radio Shack insulated wire. This is just a straight piece of wire. This is some uninsulated wire that I wound up in a coil. Yeah, so these are your very, very small inductors that you cannot find anywhere on in any catalog because they just don't make Very, very, very small through-hole inductors. I mean, one of them basically a straight wire. So I think that's it for the guts of this thing. You know, the design, it seems to work. I need to put my scope on it and figure out what's going on between 90 megahertz and 107 megahertz, where it's the frequency counter's kind of upset over it. You know, that we're reading some harmonics or something's a little bit goofy in there. Probably due to my lack of attention to detail and all these wires running all over the place. I did try to keep, you know, the nasty AC stuff back here and the RF and DC stuff up there. But that's it. Oh, and the case, this aluminum case came from Jadenco Electronics, is one of theirs. Drilled it out with a drill press, cut out the square hole for the meter with the nibbling tool. Very handy. And that's the RF signal generator that I built.